The four fundamental forces. Before we get into the four forces, let us first understand what force is. Force is defined as any interaction that, when unopposed, will change the motion of an object. There are two ways a force can interact with matter. It can either push. An example of this is a heavy box being pushed across the floor by a man, or it can pull. An example of this is the box can be pulled, as seen by this man pulling the box with the chain. There are four fundamental forces that govern the universe. The four fundamental forces are gravitational force, electromagnetic force, weak force, and strong force. The first of the four is gravity, the force that we interact with daily. Gravity is the force that attracts a body toward the center of the earth or toward any other physical body having mass. Gravity is the force that keeps us on the earth. It is the force that makes an apple fall from a tree. Gravity is considered on a macro scale and is the weakest of the four fundamental forces. This is surprising because gravity is what holds the moon in orbit of the Earth and even holds the Earth in orbit around the solar system. The amount of gravitational force felt by two objects is dependent on their mass and their distance from one another. This can be seen in an equation. F is equal to the gravitational universal constant times the mass of object 1 and mass of object 2 divided by their radius squared. The Earth's gravitational force, or Fg, is equal to 9.81 meters per second squared. The electromagnetic force is very important in our day because it allows us to have electricity and powers all of our technology. Electromagnetism takes two forms that seem very different but are actually very similar: the electrostatic force and the magnetic force. The electrostatic force is what causes you to shock a friend when you shake their hand, or what causes your hair to stand up when it is next to a balloon. The magnetic force is responsible for magnets being able to attract certain metals, like this nail. To better understand electromagnetic force, let's break down the two forces. First is electrostatic force. Electrostatic particles are broken up into two charges, positive and negative. In electrostatics, opposites attract. Negative to positive. When a negative is placed near a positive charged particle, it is attracted. However, when a positive is near a positive, they repel. The same would hold true for two negatives. The magnetic force is similar, but also different than the electrostatic force. Unlike an electrostatic particle, magnetic fields have both a negative and positive area. This causes the north and south poles in a magnet. The north pole of a magnet is attracted to the south pole of another magnet, but repelled by another north pole. However, if a magnetic substance interacts with the magnetic field, it is attracted to both poles. To bring it all together, it is important to note that charges can cause a magnetic field when they are passed through a coil, and a magnetic field can cause a current through magnetic flux. This shows that these two forces are the same. Therefore, the force is called the electromagnetic. The weak force is much smaller scale and more complicated than the previous two forces, but is important because this force is what causes particle decay. Weak force acts over very small distances, and the force carriers for weak force are W bosons and Z bosons. To understand how the weak force works, let's see it in action. Here is a neutron and a neutrino. A neutron contains 2 down quarks and 1 up quark, and a neutrino contains a positively charged W boson. If the two get close enough to interact with the positive charged W boson, will go to the neutron. This is the weak force. The positive W boson will change a down quark to up. As a result, the neutrino is now an electron, while the neutron is now a proton. Since the nuclear components changed, the atom has changed, and therefore undergone particle decay. The strong force is the most powerful of the 4 forces. It holds our atoms together. This force that holds atoms together is sometimes called the color force. Protons and neutrons are hadrons and are made up of quarks. Quarks and leptons are the most fundamental forces of matter. Now let's look at strong force in action. Gluons are the force particles that make the strong interactions happen. They have no charge or mass, but are able to change the color of the quarks. Now consider this 3-quark molecule and the gluon as seen in gray. As the gluon's in the green, it stays green, but as it leaves, it changes the green to red. And as it enters the next quark, it changes the red to green. This changing of colors is the color force that keeps the atoms together. Quarks are never observed alone because of the color force that acts like a rubber band keeping them together. The color force is the reason that 3-quark hadrons, or protons, are so stable. In summary, there are 4 fundamental forces that govern the universe: gravitational force, electromagnetic force, weak force, and strong force. These forces describe energy at work in all places and at each level in the universe.